So hi everyone, and I'm pretty sure you're wondering, what do mirrors have to do with astronomy, right? Well, as a kid, I was really fascinated to see pictures about the universe. And whenever I attended public astronomy talks, I was always interested to see these astronomy pictures of the universe. They are beautiful, right? Well, this is super exciting, but I was always interested in who are these monsters behind these beautiful pictures? In a sense that, by monsters I mean telescopes. Who are these telescopes that are actually taking these beautiful pictures of the universe? Where are they? Where are they located? How do they even look like? So, during my PhD, well, I'm still doing my PhD, but in the past 3 years...
Just closer.
Okay. So in the past 3 years, I had the chance to go to an observatory, to an actual observatory. It's located, can you hear me?
Yeah.
Okay, sorry. So in the past 3 years, I had the chance to go to an observatory. It's called the La Silla Observatory. And it's located in South America, in Chile. And it's so far away from any source of light pollution. You don't want the telescope to be close to light pollution. So this telescope is located in the Atacama Desert at an altitude of 2,400 meters. And every night, this telescope that you see, it would open its mirror cover and it would observe targets that are in the night sky. So technically, we will collect light from objects in the night sky, and this light will be reflected into optical instruments that are often mounted at the telescope. And then this data is saved, and astronomers would actually look at the data and do their analysis. So this is actually very interesting, but the most important part is that these mirrors, they have to be reflective, because we want to collect light as much as possible. So every 4 years, these mirrors have to be cleaned, in a sense that we have to do the recoating of the mirror. So these mirrors, they have an aluminum layer. Every 4 years, this aluminum layer should be actually removed, and it should be replaced by a new one, by a new and a shiny one. And you would think that this process takes 2 hours, right? We just put in some water on the mirror, clean the mirror, and we're done, right? Yes or no? Well, actually, this is not the case. This process is a very, very, very delicate process, and it takes 5 days to actually do it, not hours. So during this process, we're not allowed to scratch the mirror. We're not allowed to damage the mirror. We're not allowed to do that. Because if anything happens to the mirror, if something goes wrong, we don't actually have a replacement of this mirror. So we really have to be careful not to do anything wrong. So just to give you a quick look up at how the process is. So the first step would be to remove this primary mirror from the telescope. So we actually need to detach the mirror from the telescope. And to give you a feeling of what sizes are we talking about, well, this is the actual mirror. So it weighs 3.3 tons, so it's very heavy, and the diameter is 2.2 meters. So I think you can now appreciate how heavy the process is and how difficult it is. So even you can see the width of the mirror. It's very, very thick, and it's 3.3 tons. So you can already see also that the mirror is not reflective anymore. There's a lot of dust on this mirror that has to be cleaned. A closer look at the mirror would reveal that there's definitely a lot of dust. And these lines that you actually see on the mirror, these are water droplets that just fall on the mirror. And during the night, when we are observing with the telescope, usually the telescope just changes position in the night sky, and then these water droplets would just move on the mirror, producing these lines. So these are actually lines of water droplets, and the mirror is just chaotic. It's full of dust. And one more interesting thing, we actually saw something which was unexpected. It's not related to frogs, I promise, but it might be related to something else, which we don't know what this is. So you can see that there are these small black dots on the mirror. We don't know what these are. I have a suggestion, but I will leave it up to you to think what these things are. So the mirror is definitely dirty, and we really have to clean this mirror. So the second step, after we detach this mirror from the telescope, would be to put the mirror in this yellow box. and transport. So the mirror was inside the silver dome. We removed it from the telescope, we put it in this yellow box, and then we have to transport it all the way up to where the white dome is. And this is called the 3.6 meter telescope, because astronomers are very creative when it comes to names. All right, so usually this drive from the silver dome up to the white dome, it takes 2 minutes. But during this process, it actually took around 20 minutes, because the driver is not allowed to drive fast. And the driver is actually not allowed to hit the brakes, because we do not want the mirror to move inside this box. So the driver has to drive very slowly, very carefully, and even you can see this white car in front of it, which is actually escorting the mirror. So please don't touch our mirror. So after the mirror actually reaches the white dome, the first step would be to just pour in some water in order to remove the dust. And the second step would be to put soap on the mirror. So we're not allowed to make any scratches, so we have to put the sponges like each step at a time. And this process is like repeated around 7 times, because we really want to remove any dust that has been accumulating on the mirror for the past 4 years. Yep, so after we remove the dust, the second step would be to apply what we call the green river solution. It sounds perfect for a cocktail drink, but it's actually not. You don't want to drink that, so it's an acid. You would pour this acid on the mirror, and this would actually remove the aluminum cover that is present on the mirror. So you can see that actually we don't have an aluminum layer anymore. It is being removed using this green river solution. So it's quite interesting, and the final step would be to apply propanol. So we use this to remove any aluminum layer that is still present on the mirror and to remove any dust. So after we've washed the mirror with water, with soap, with the green solution, and with propanol, we have the final wash for the mirror, and we apply what we call CO2, just CO2. So it's it's like snow, in order to remove any dust that are still leftovers on the mirror. Hopefully there are none anymore. And then we move the mirror. We put the mirror on the aluminization chamber. So this is, you can actually see the door of this chamber, and then the mirror is actually put inside this chamber, and we close the door because it has to be a vacuum. It's a vacuum chamber inside. So this was actually the end of the day for us. So we had to go for dinner and then spend the night. But the next day we were super excited to see, so did we get our new mirror? Did we finally get to put a new aluminum coat on the mirror, and does it look good? So the moment of truth. We have our new shiny mirror. I hope I convinced you that it's very shiny and it's very new, and hopefully no dust on it. And this is actually the last test that we performed in order to check that the mirror is clean and the reflectivity is really high. Yeah, so with this final step, we actually now have our new mirror. It's new and shiny and clean, and the mirror is ready to be transported back to the telescope in order to continue doing our observations and hopefully observe the universe. But in my last slide, I would like actually to show you the group that was actually involved in doing the recoating of the mirror. So I've been to this observatory a lot of times, but I often spend time with astronomers, and I always thought, yay, it's an astronomical observatory, it's full with astronomers, and astronomers are so cool. It is correct, but I often, I promise it is correct, but I often underestimated how much energy, how much engineering actually is involved in astronomy, and how much technology. So after my trip, I appreciate a lot now the engineers, and I think astronomy wouldn't be the astronomy as we know it now without those engineers. So the next time you go and observe, or the next time you actually look at an astronomical picture, make sure to remember those engineers and thank them. Thank you.